This video going to be a short video that is retinal image size in uncorrected and corrected metropia. Let's just move forward and quickly see what is this. So two type of metropia I'm currently discussing, and one is axial metropia, metropia due to the axial length. Another is refractive metropia. See, another is refractive metropia. So then in this case, refractive metropia. And axial metropia means the metropia because of axial length. So you can see in this picture, figure 15.1, in if metropia the image size is this, then in case of myopia image size is definitely larger, and in case of hyperopia image size is definitely shorter. So in case of axial metropia, shorter the axial length, smaller the image size, isn't it? It's very simple. So in case of axial myopia, shorter the axial length, which creates a smaller image size. It's period, no doubt. But in case of uh, refractive metropia and in case of uh, emmetropia, not emmetropia, but emmetropia. In case of refractive emmetropia, image is blurred but does not affect the image size. This is this line. Can you see this line? So B line. Yes, emmetropia and emmetropia in case of refractive. I'm telling you, in case of refractive, not in case of axial. In case of refractive, image size is same but not focus of image. Definitely in case of emmetropia, focus is blurred and we have to correct it, but image size remains same whether it is hyperopia, whether it is myopia or emmetropia. Three conditions have same image size, but image definitely be blurred because of emmetropia. But in case of refractive emmetropia, you just remember all the conditions have same image size. But in case of axial emmetropia, shorter the axial length, smaller the image size. So it's central important. Okay, let's move forward. So I'm directly going to talk about the retinal image size in case of emmetropia when we correct it with the contact lens and with the spectacle. Yes, definitely in case of spectacle, we have to understand the Knapp's law. Okay, according to Knapp's law, we are talking about this, and in contact lens, yes, definitely optics of contact lens. I'm going to talk about optics of contact lens when I will talk about contact lens series. We are currently in optic series. Okay, fine. So this is a chart I want to explain. So see, retinal image size when emmetropia is uncorrected, when emmetropia is corrected with contact lens, when emmetropia is corrected with spectacle lens. Okay, so all three things in millimeters. So in emmetropia, we don't care, it's x and x. So which means x is standard. Okay, so greater than x means greater than emmetropia, lesser than x means lesser than emmetropia, smaller than emmetropia, isn't it? See, if axial myopia is uncorrected, then the size of the image must be larger, isn't it? So if axial hyperopia is uncorrected, then size of the image in retina should be lesser. That's what we have talked about in last slide, isn't it? So in refractive myopia, uncorrected myopia doesn't matter, it's same, isn't it? It's same in if refractive hyperopia. In case of refractive, we don't care about the size, it's all same whether it's emmetropia, whether it's myopia, whether it's hyperopia. But in case of axial, we know the longer the axial length, larger the image size, shorter the axial length, smaller the image size. Okay, fine. So in case of emmetropia, we don't need to talk about correction. So in case of axial myopia, if we correct axial myopia with the spectacle, see, with the spectacle, that's why axial myopia and axial hyperopia should correct with the spectacle. If we correct with the spectacle, then the size of image fall same like emmetropic, isn't it? That's what we talk in Knapp's law, isn't it? So that's the one thing. And another thing, you see, if we correct axial myopia with contact lens, what happens? The image size is greater than uncorrected, isn't it? Greater than emmetropic. If refractive myopia and refractive hyperopia is always corrected with contact lens, isn't it? So refractive myopia and refractive hyperopia should correct with contact lens. If we do that, then image size resembles with uncorrected state. So the moral of this story, see, if refractive myopia and refractive hyperopia, if we correct it with the contact lens, what happens? Refractive myopia, let me clear it up for you. Okay, if we correct refractive myopia and refractive hyperopia with contact correction of spectacle, what happens? If we correct refractive myopia with spectacle, then image size is lesser. And if we correct refractive hyperopia with spectacle, image size is greater than what? Greater than uncorrected, greater than emmetropic, isn't it? So you have to understand like this, okay? So another, what we know should not do, if axial myopia, this condition axial myopia and axial hyperopia is corrected with contact lens. See, if axial myopia is corrected with contact lens, then image size is greater than emmetropia, and axial hyperopia is corrected with image size is, what happens if axial hyperopia is corrected with contact lens? Image size is smaller than uncorrected. So that's what happened. Okay, in this chart you can understand what should be done. Okay, I'll round it up. What should be done? See, this should be done, that refractive hyperopia and refractive uh, myopia should correct with contact lens, and axial myopia and axial hyperopia should correct with spectacle lens. But it's not like in clinical cases. Okay, so many of the time in clinical cases, if it's pure axial myopia, then we have to choose contact lens, because in real scenario it depends. But in theoretical purposes, that's why Knapp's law we have to talk in a separate video. Knapp's law itself has fallacies and all these things. So there are a lot of things we will definitely going to contradict when we are talking about ophthalmic dispensing, when we're talking about contact lens. So we have to make another series of videos. But for now, this is it. You have to understand this is the sequence, and uh, please go through this book, because today's presentation I have made all from this book. Good book and my favorite book. I didn't touch the George Assimili's book, because I'm taking it for the later videos. Okay, for today, bye.